This story began 4 years ago when I came across this picture titled Loaf from the Future, and we started building it having only a single image from one angle. But after 2 years, we finally managed to finish the technical part, and as a result, we got a fully functional electric car on air suspension controlled by a joystick. Now, all that was left was to finish the exterior, or so we thought.
Where's the loaf? What's going on with the loaf project? A year has passed, so where's the loaf? And what about the previous loaf? I'm really looking forward to the finale. Where's the loaf? Where did you put the loaf? When will the episode about the loaf come out?
Yes, over the past year there have been a lot of questions about the loaf. Many people, quite reasonably, have come to believe that we abandoned the project, but that's not the case. And now you could say the second season is coming out, which will end with the project's completion. We've firmly decided not to publish any new projects until we've finished all the old ones. In the meantime, the loaf is slowly making its way into the workshop and coming back to life before our eyes. So, the last episode about the loaf came out a full year ago, and then we disappeared. I think that over the course of today's episode, it will become quite clear why there was such a very long gap between episodes. The thing is, in the last episode, we carefully covered the sides with polycarbonate and ran into the significant issue that we specifically needed to cover the windshield and the rear part, both of which are distinctly curved. It might seem like a pretty simple task. Just lay a sheet of polycarbonate, bend it precisely here, and that's essentially it. But it's truly not that simple. If you do it that way, the front part will look really quite cheap, much like the Cybertruck with a flat sheet that genuinely does look rather cheap. So we realized we absolutely needed to do something much more complex, something truly spherical, and that's actually a very difficult and challenging task. That's precisely what we're going to tackle today. Let me show you once again visually what we're trying to achieve. We need to get glazing like this, but if we take the easy route, we'll end up with something like this. So let's open up the software and model a small section. This is the lower part of our windshield. It looks like this, and now all that's left is to bring it to life. First of all, using our highly efficient and precise CNC machine, we meticulously cut out a significant number of individual elements, much like these carefully crafted components. We precisely cut these elements from high-quality medium-density fiberboard, commonly known as MDF, which is a versatile and reliable material chosen for its excellent workability and consistent finish. After several dedicated hours of continuous operation, we successfully produced our very first complete kit. This meticulously crafted kit is designed to be assembled quickly and with exceptional precision, forming the required robust and perfectly aligned frame ready for its intended purpose. The next step is to use a laser cutter to make small longitudinal cuts on a sheet of plywood. This is done so that the plywood becomes more flexible and can take the shape of the frame. In the final stage, as you can clearly see, this is skillfully done using a pneumatic nail gun. In fact, we specifically needed to cut out 3 different small shapes, and we meticulously made them in various ways. So later on, you will undoubtedly see other molds, but the fundamental idea is essentially the same: to precisely shape a transparent sheet of acrylic over this mold. We cut off a piece of that very transparent sheet, load all the ingredients into the car, and set off in search of adventure. 10 kilometers from the workshop, we have another facility where we dry and store lumber, mainly slabs for tables. That's where we headed. Here's the idea. We decided to secure the acrylic sheet with 2 wooden bars on both sides, place this assembly on the carriage, and send it into our cool, smart drying chamber. That's exactly what we did. We rolled it in, closed it up, and started heating it to the desired temperature. As a result, for forming, the workpiece needs to be heated to 150 degrees. Then you have to quickly open the chamber, take the red-hot workpiece out of the oven, place it on the mold, and shape it as needed. How I miss those times. Back then, it seemed like an extremely simple task, and we thought we'd form all the parts in just a couple of days. In the end, in order to properly heat the workpiece to 150 degrees, it took us more than 8 hours. And finally, the moment arrived. We saw the cherished temperature of 150 degrees and got ready to quickly open the chamber, take out the plexiglass, and get the long-awaited workpiece. Let me remind you, everything is heated to 150 degrees, and when you open the chamber, a huge volume of hot air rushes out. As you might have guessed, we never got the coveted part, but we did end up with an interesting decorative piece and our first experience. The thing is, as the plexiglass was heating up, it was also stretching under its own weight. As a result, the sheet sagged so much that it rested on the metal frame and started sticking to it. But that's okay, we still have another piece of plexiglass, a cool drying chamber, a few accomplices, and a huge desire to finally mold a transparent blank. We make a few small adjustments and start the process again. This time we made the blank a bit smaller, raised it a little higher just in case, laid a flat metal sheet underneath and set up a more delicate program. In other words, the maximum temperature will be 140 instead of 150 degrees. And so after another 1 to 8 hours of waiting, it's time for the long-awaited unboxing. Let me remind you that plexiglass is formed within the first 20 to 30 seconds, and after that it cools and doesn't yield. In the end, this is what we got, and honestly, I'm really satisfied. This is the first successful result. This element will be installed right here, below the glazing. I think it looks crooked on camera, and it actually is crooked, but only in these spots. The usable area that we're going to take is about this size, so here it's perfectly straight. Accordingly, we'll now cut off the necessary piece. We bent it with some extra length because it's easier to shape that way. And just to repeat, we insert it here into the lower part, and now we need to make this larger section. It's exactly the same part, but about 10 times bigger. It's not an easy task, but we're about to get started on it. But while we're moving on to the next more challenging task, Andriy is slowly starting to work on the first small part, which is exactly how we planned it. First, we'll go through the entire process using the small part as an example, make sure everything works out, and only then move on to the larger one. Here, the process is exactly the same. We model the front part, create a small sphere, and send the file off for production. Now, we need to precisely machine the exact same front part of the car, but at its full, actual size at a complete 1:1 scale, and it's just absolutely enormous. Even though we possess pretty large and capable CNC machines, we still had to carefully split this substantial model into two distinct parts, but let's take it step by step. While the CNC is cutting out blank after blank, let me tell you a bit about where we disappeared to with the bukanka. I think no one would argue that molding such a huge part is not the easiest task. We understood that too, so we decided to turn straight to the professionals. We spent a long time looking for someone who could help us with this molding on the condition that we would make and deliver all the molds ourselves. We called every company involved in this kind of work. We were ready to pay triple the price, but eventually we found some who agreed to do the molding. It seemed like we finally got lucky. In the end, we sent them the mold, then waited a very long time, tried to be understanding about their delays, sick leaves, and endless promises, and after a couple of months, they refused, saying the part was too complicated. But in reality, these so-called experts ruined the mold and couldn't admit it. All in all, this whole saga dragged on for more than half a year, and at that point, it became clear once again that we would have to do everything ourselves. As a result, we ended up with these two things and once again geared up for battle, this time bringing Kolya along with us. The thing is, this time we needed to perform pretty much the same operation, but the sheet of Torx glass would be 10 times bigger and obviously it wouldn't fit into the chamber the same way, so we came up with the following solution. Initially, our task was to fit a polycarbonate sheet measuring 2 by 2 meters into a chamber that was 1.5 by 1.5 meters. Without much hesitation, we decided to bend the sheet into an arc and place it in the chamber in that position. But to do this, we needed to modify the design and weld supports that would hold the sheet in its curved shape until it was heated. As a result, in just a couple of hours we welded this simple structure. 2 frames between which the bent sheet of acrylic will be placed. Here is the first fitting, which was basically successful. We realized that the sheet could be bent to the required degree, and now we just had to figure out how to secure it in place. First, we decided to make a test piece. Basically, the setup seemed workable to us, so we proceeded to drill the acrylic sheet according to our plan. We mark it out, drill it, and go hole by hole like this. The very next step is to carefully check if the cable fits perfectly through the designated hole. Everything appears to be fine here, which means we can now unpack the protective sheet and finally secure it firmly in its proper place. That's precisely what we did, and then we faced another significant challenge. The essential thing is, we needed to figure out how to securely fasten the sheet in place. Even though it's currently held pretty firmly in the frame, that's only a temporary measure, and as soon as it inevitably starts to heat up, it will undoubtedly end up on the floor. Look, in theory, we could potentially make just as many additional holes between the existing ones. No.
Not exactly. It actually starts to splinter, see?
We could make a small hole here and say put some kind of a simple stopper right here.
What will it rest on? It'll only have one point of support on this side, and when it starts pressing down, it'll sag. How do we make...
Not a stick, but a bracket.
Yeah, theoretically, yes. In principle, we could. With clamps, with those zip ties. And then, to quickly remove all of this, you just take a knife, someone runs along, tap, 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 cuts them off. Well, you just cut these off.
The question is, will it hang on the zip ties? Do they melt or not at 150 degrees? A zip tie works like a ratchet. It gets soft, tick, 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 and then it slips and falls off.
Yeah, that could certainly happen. Here, we carefully drill, and then we just put it on like this, right up against the stop, precisely.
Look, we tie a knot right here, so the overall length doesn't change basically for this particular setup. Here we drill a hole, insert a bolt, just put it in, and then we gently pull it out, and everything is released. Everyone comes from their side, grabs the handle, pulls out their bolt, and it's free.
Yeah, that also works too.
In the process, we realized that the previous fastening option didn't suit us, so we quickly came up with the next one on the fly. So, what's the idea? Now we need to put this thing in the oven to heat up the polycarbonate, or rather, this is acrylic glass. And accordingly, right now it holds itself in place because it's wedged between these supports. But when it starts to heat up, it will become more pliable, sort of soft, and as a result it will start to sag. And it will fall down. We need to somehow secure it so it doesn't fall down, and we've come up with the following fastener. But there was also a requirement that when we take it out of the oven, heat it up, we'll have about 5, 10, maybe 15 seconds to remove it and quickly place it onto the mold. So it needed to be some kind of quick release mechanism, and in a pinch we couldn't come up with anything better than this kind of fastener. So when we take out this heated material, it will sag a little like this, and it will be fixed in place in this way. That is, there are 12 bolts located here, with a clamp securely placed in each and every hole. And we will assign one person to each individual bolt, so they can quickly come up, grab this rope, gently lower it a bit, remove the bolt, and then using these very same handles, we will immediately carry it over to the mold. What will this entire process look like in real life? We don't know yet, but you'll definitely see it all very soon. But from here there's not much left to do. Install clay bolt stoppers as limiters, lay down a silicone mat in case the acrylic sags and rests on the base. And hopefully we've thought of everything, so we send the blank into the oven. In order to properly and effectively control this entire process, we absolutely need to accurately know to what precise temperature our acrylic material has been thoroughly heated. Accordingly, we will carefully leave this essential sensor here, and now we'll meticulously drill a small precise hole and then gently insert it there. Actually, all this preparation is necessary because it's not as simple as it seems. As unbelievable as it may seem to me personally, I think it's not as simple as it looks. This material, acrylic, absorbs moisture. And accordingly, if you just immediately heat it up to 150 degrees, the release of this moisture will be intense and it will most likely come out in spots or bubbles. Basically, that's not the right way to do it. The correct way is to heat it up to 80 degrees and maintain that temperature for an hour so that all the moisture can come out gradually. Then, after holding it at 80 degrees, we heat it up to 150 degrees, take it out, and then form it as needed. This is the right approach, but in order to maintain all these temperature pauses and heat it to the required temperature, we use sensors. In addition to the two sensors that we inserted into the material, we also have sensors in the chamber, so we can monitor both the overall temperature and the temperature of the material itself. And accordingly, this is the most accurate approach we can take under our conditions. The next step is to heat the material at the correct intervals, with pauses, holding times, and so on. As a result, this process takes more than 8 hours, which means we have time to prepare the mold. As you remember, the main large mold consists of two elements. Now they need to be perfectly aligned with each other. We symbolically tape the joint and stretch fabric over the mold. This is something like a lining material, so as not to accentuate any flaws in the mold. And in theory, the glass should actually form much more neatly. And now, after 8 hours, the long-awaited hour X has arrived. Let me remind you of the entire sequence. We need to very quickly open the vacuum door, which is secured with numerous bolts. Then, this red-hot 200 kg door needs to be quickly moved aside. At the same time, you need to roll out the cart on which the workpiece is fixed. Then, at the same time and very quickly, we need to remove 12 limiter bolts, while hot air is coming out of the chamber and everything around is heated to 150 degrees. So that's the task we have ahead of us. Let's see how it turns out. So, another experiment. Instead of glass, we ended up with some kind of art object. It's a bit disappointing and annoying, but overall, everything's okay. We realized that we can heat up such a large sheet. It became clear that we just need to fasten it differently. The spots where we ran the cable through couldn't handle it. They stretched and tore. As a result, it fell and ended up sticking to itself. Basically, it takes shape perfectly. So, for example, this particular straight piece that stayed firmly on the mold with its perfectly flat surface successfully took on the desired and intended shape. Which means, consequently, we just need to fasten it differently. Acquire another sheet of this specific plexiglass, which, as you know, isn't exactly cheap, then heat it up in precisely the same mode and very carefully stretch it. So, the experiment was partially successful, but not this particular time. And now I truly hope that next time we'll get it absolutely right. We're making adjustments, and already the next day we're getting ready to take out another blank. And here I have a question for you. What do you truly think? How much does one such attempt actually cost? That is to say, we stop our entire production for a full day just to use this specialized chamber. Then, we subsequently buy another sheet of plexiglass and heat this enormous chamber with electricity for 10 hours. After that, we need to organize 12 workers and 2 operators to carry out the unloading. So, here's the question. What do you think? How much does this cost? The thing is, I'm actually afraid to even calculate it. I suggest we discuss this in the comments. Unload it, just step out and stretch it out a little bit. Great, great. Come on, come on, come on. That's it, tension it.
Yes, just smooth it out a little. No, it's fine, it's fine, it's fine. Everything's great. What are you doing? Fire! Fire, fire! What kind of fire is that in your hands? Blow on it, blow on it, blow on it. By the way, that was a good one.
Walk around in a complete circle, Andriok. No, really, it's absolutely nothing serious at all. Believe me, I assure you. You'll have to open the door.
As you can see, we changed the mounting method and fixed the edges using wooden slats, but doing this with one big slat would have been wrong since it doesn't allow you to properly stretch the plastic over the mold, so we divided the slat into many pieces. In the end, we cut off the excess pieces and just look at how huge they are and how... Yeah, damn it, you shouldn't be pulling it out. Not dwelling on that, we send the blank to the workshop for the first fitting. To be honest, this is kind of... Anyway, it's fine. We bent the glass, sent it for delivery here, and the next day I come in and this is what it looks like. In short. Basically, it arrived in pieces. And to be honest, I'm starting to lose heart, because each of these attempts is expensive and difficult, but at least it became clear why this happened. It happened precisely because we were actively stretching it, and as a direct result, the edges became incredibly thin. So, originally, we were carefully shaping this 6mm thick glass material, and when we stretched it out, it literally transformed into about 2mm in thickness. And accordingly, the closer to the edge, the thinner it gets, and therefore it's extremely fragile. And so we just set it on the edge during delivery, and a crack appeared. It sat there with a crack for a bit, and that was it. Well, actually, there's really only one significant upside, that it happened right now, and not after we had already put it on the car, because it's definitely very fragile, extremely thin, and these particular installations aren't truly suitable for the car. Well, we'll certainly have to think of something else entirely. And then our thoughts turned to the following. We have this kind of drying chamber, in which we need to heat up a huge piece of acrylic glass. As you can see, our mold doesn't fit in there at all. Now it's already clear that we need to use thicker glass and that it shouldn't be stretched. And so we couldn't come up with anything better than building the dryer around the mold. So that's exactly what we'll do. Especially since you probably supported us by ordering a set of stickers. Thank you so very much. Now we have a little bit more money for another attempt. Since this is a very temporary structure, we decided to make it out of whatever we had on hand, because the next day we'll take it apart and throw it away. The main goal is for it to be quick, simple, and cheap. And of course, it held the temperature perfectly. So what exactly does our current structure look like?
It's comprised of two completely independent halves that smoothly slide apart and then securely rest on the sturdy surface of our oven. Subsequently, our carefully prepared mold is precisely placed in the very center. We'll put the acrylic sheet on top of it, and theoretically, the oven's heat should effectively transfer to this attached part of ours, and then, under its own weight, it will gently stretch over the mold. Our previous experience has clearly shown us that we can heat and stretch acrylic at 150 degrees, and that's enough for us to stretch it over our mold. But we previously used 6mm acrylic and stretched it significantly, and in some specific places it became very thin, indeed, down to 4 or even 3mm. Now moving forward, we are going to utilize 8mm acrylic, heat it a bit less carefully, and diligently try to preserve its original thickness.
But from here, all that's left is to start the process and hope that everything works out.
So we're checking the intermediate results. According to the sensor, the temperature of the acrylic is 115 degrees. Let's see what we've got there. So we can clearly see that the acrylic has started to take its proper shape, but the outer edges haven't fully formed just yet.
And now, after a couple more hours, the sensors showed the required temperature. Through the window, you can see the formed acrylic. And now we need to quickly remove our wooden frame. And if necessary, you can finish shaping the piece by hand or adjust something. Let me remind you, all of this is heated to 150 degrees.
So I'll briefly explain our experimental setup and precisely what was happening here. We carefully placed the acrylic sheet on top of the mold and securely fastened it with heat-resistant silicone bands. In the meantime, we could conveniently check the condition of the polycarbonate through our small, transparent little window. The acrylic sheet didn't stretch very much and consistently retained its original thickness. On average, it's about 9.5 millimeters thick. Overall, this is probably our most successful experiment. The next step is fitting it onto the car.
The very next stage is another important delivery and the very first real fitting and adjustment process.
we continue installing the windshield on our van. As you might have guessed, we couldn't technically make the front windshield part of the car in one piece because the shape is too complex. That's why we made it out of two parts. This is the lower part, which is basically the bumper. And we will mount these parts together, joining them edge to edge. We'll try to make this seem as transparent as possible. I don't know yet what they've come up with. We'll fill it with something, glue it with something. We haven't really thought about that just yet. Next, there will be a protective cover placed on the tank. It will be carefully installed to round out the entire shape. And there will also be another seam on the roof. There will also be a transparent seam, a clear and visible line somewhere around this particular area. Now, when the robust polycarbonate material for the roof eventually arrives, we'll carefully cut the front part of the car's structure to precisely join these two distinct pieces together. We temporarily fastened the car's front panels securely with specialized roofing screws that are equipped with protective rubber washers. We also thoughtfully placed a soft cushioning piece of foam under the metal profile, which is specifically supposed to accurately imitate the exact thickness of the adhesive material. Later, we'll intentionally leave only small, precisely cut squares to serve as crucial spacers for the adhesive as well. For now, we'll carefully trim it after the initial gluing process because until the adhesive fully sets and cures, the front panel will be securely held in its proper place by the strategically positioned screws, and the very same foam material will effectively maintain the necessary spacing. The cutting line, as you can observe, is positioned extremely close to the screw holes, and we're genuinely concerned that a significant crack might potentially form here due to the high tension and considerable stress, especially since the panel is slightly stretched and conforms tightly over the profile. So, to mitigate this risk, we'll glue it first. We know precisely how to properly glue glass. First, apply a suitable primer to the glass surface and the vehicle body. Then carefully apply the adhesive. Subsequently, press the glass firmly to the body so that the adhesive spreads out evenly, and that's exactly how the glass is securely glued in place. But that's not at all the case in our current situation. Most likely, with this particular method, if we do everything ourselves, we'll inevitably smear glue everywhere, completely miss the screw holes, and the delicate glass won't fit properly into the main body of the device. We've already applied primer to both surfaces, put the glass in place. There's a wide gap here between the glass and the body, and now, using a tube with a thin nozzle, we'll inject adhesive into this gap. We thoughtfully and carefully applied this particular foam material so that the adhesive wouldn't get pushed onto the very front side of the glass, and so it wouldn't be squeezed out on that side. We have a protective barrier in the form of the foam material, which is quite effective. On this side, there's a huge gap where we're injecting the adhesive, and then we'll press it into the glass. In theory, it's all simple, but we'll see how it works out in practice.
And finally, after 6 months, we really spent 6 months making this glass. It's finished, installed, and we are completely satisfied with it. It's strong, thick. Basically, we managed to make exactly what we wanted. We're very happy, and we've also finished the rear glazing. Everything fits perfectly, and we'll show you now. We bent the top and bottom parts, and in the center we have a straight sheet, so there will be neat small seams here. This also just needs to be glued in and covered with film. And now I have a question for you. We need a transparent mirror film. Maybe some of you work with these kinds of films or know which one would be best to use. Please be sure to write in the comments or email us directly. The email will be in the description.